Right, so this is AP Calc A/B Test 2007, question number 1. It's a calculator problem, so all this is done by calculator. All right. It says let R be the region in the first and second quadrants bounded by the graph of the rational function 20 over 1 plus x squared and a horizontal line y equals 2. So I quickly put these into my calculator, and then it says find the area of region R. Well, the first thing I want to do is figure that out. So I have two screenshots. First one here, to get the whole curve in, I know that the y-intercept was 20. So to get the whole curve, it had to be a pretty big picture. So here's region R. All right. Truth is I don't need that picture. Nope. As long as I realize it's happening in between here, right? And we realize that the top curve is the rational, and the bottom curve is y equals 2. I then window in, and I found the intersection between those two lines, and it was at 3 and 2, obviously. I used my calculator, and I quickly, what do we know about this rational function? What kind of function is it? Odd, even, or neither?
Even.
Even. If we plug in negative x, we get the same function back. It's even. So what do I know about the other intersection point? If it's 3 on the right, it's negative 3 on the left. So I automatically know that. So now I'm going to find the area of the region. And this is not that hard. I'm going to say, hey, and because I'm doing it on my calculator, I have two choices. I could do this. Do you guys agree? But since I'm doing it on my calculator, do you guys agree it's this, and then it's this, minus this, dx? All right? The integrant here, this integrant was worth a point right now, so if you have this written, you get a point. Now the answer is going to be worth a point, and I'm going to show you that I have a snapshot of that. I don't know. Oh, hang on. Let's see. I'll put the screen up. Oh, the calculator came off. Should have this number. All right, 39. Yeah. Point. Same number. I don't know how. So let me see what integrant you have, and I put that on here. So you get 39.9618. Or 37.9618. All right. So there's 2 points total. One for the integrant on the left, answer of 37.9618 on the right. I'll scale this down. We'll start part B. So part B says now find the volume of the solid generated when R is rotated around the x-axis. All right. Even though I have the calculator trails, I would probably take one.
The outside. The inside is always 2. The outside is function.
Exactly. You're spinning it here. Do you guys agree? There's an RI and an RO. And I might just sketch that up real quick. RI is the function y equals 2. RO is the rational function. And again, this is a washer situation. All right, so again, even though I can go awfully quick, I know it's from negative 3 to 3, and I'm doing AX dx. You guys agree? Volume is going to be equal to that. So, and again, this is not exactly AP thought process, but I write this so I know I'm getting the right formula, and that'll really prove important on letter C coming up. All right? And now I know this time RI is simply 2, and I know RO is the function, the rational function 20 over 1 plus x squared. So I will do 2 steps at the same time. I'll plug it.
Isn't it that minus 2?
The
RO? Not minus 2.
It's not minus 2.
Why is it minus 2?
How far is it from?
That's the inside.
Okay, it's not minus 2. How far is it from here to here? It's y, which is that distance. Minus 2 is going to happen right here.
It's going to be the outside.
Oh.
Minus
Now I'm going to bring the pi out, and I'm going to write parentheses 20 over 1 plus x squared minus 2 squared RO RI dx. That is the integrant. That is worth 2 points. You have to have it all right? Now, what we have to do is simply plug this into our calculator. All right, so I'll use the TI. And again, if I type that into my calculator, and I'll actually put the pi in and go -3 to 3 of RO squared minus RI squared, which comes off the screen dx, your answer comes out to be 1871.1901. So I would just set that equal, and that number was worth 1 point. All right, so far we've done A and B, and there's been 5 points total. All right, so that is part B. Let's group that and get it out of the way. Now you think there's 5 points so far, A and B, so you think C's got to be worth 4 points total, right? I'll tell you now, C is only worth 3. There is a point that you have all the correct limits. So when we do the integral of C, you had the limits -3 to 3 on that, and you had the limits -3 to 3 on B, and you had the limits -3 to 3 on A. Give yourself a point right now.
Boom.
Boom. All right. Now,
Oh, for C.
Yeah.
the region R is the base of the solid. This solid has cross-sections perpendicular to the x-axis that are semicircles. All right. So again, to really simplify this curve, we got this going on. All right. And here, you guys agree that's RI again? RO. But this time, it is not a washer. The area that is happening here is semicircles. You guys agree?
So, yeah. Okay.
All right. So what's shown here is not correct because RO and RI, this is not what happens. It's not doing semicircles here. It's doing semicircles here. You can picture it doing the semicircle here. So this distance here, okay, between these curves is the diameter of the semicircle. All right? So the volume is going to be, and again, if you have -3 to 3 on all your integrals, you got yourself a point. All right, we got this. We agree it's pi r squared over 2. But right now I don't have r. What I have here is the d, which is the rational function minus 2. And what's the radius? Well, the radius is half of that. So there is our radius. All right? It is half this distance right here. All right? Now I pull out the pi over 2. I'm going to give myself some space down here. You pull the pi over 2 out. -3 to 3. And now you have this big thing. Squared. That's the radius. dx. If you got that, that's 2 points. And again, instead of taking time and actually type it in, if you type it in, you get 174.268 on your calculator. And that is worth a point.
Yeah.
That's all we had in the AP test. We would go 4 now, right? We would take to that 4 test. So this is 2007, problem 1 with a calculator.